students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now today we will be going back to the topic factorial notation. We have learnt about the factorial notation and we have solved questions related to factorials, but I am going back to that very topic again because I have received few requests asking me to have some more video sessions on factorial notation. According to them, I did not include sufficient number of questions on factorials in my binomial theorem playlist. Therefore, I have decided to have 2 more video sessions on this topic, factorial notation. In our today's session, we will be having simplification type problems, and in our next session, we will be having equations related to factorials. In case you find the questions related to factorials difficult to solve, I would definitely be asking you to stay tuned till the end. Watch this video completely. I think you will be benefited by watching this video. Okay, so let's start with today's session. So the first question says simplify n factorial raised to the power of 2, that is n factorial whole square, minus 1 divided by n factorial minus 1. It is a very easy simplification question. Just because you are having this factorial notation, some students get confused. What if I say there is a question, simplification question, a square minus 1 divided by a minus 1? How would you be approaching this? We will be approaching this question exactly in the same way that we would have approached this question. Okay, so let's start with our answer. So, in case you are having confusion, let me write that let A be equal to equal to n factorial. Okay, then n factorial whole square will be, okay, let me write the question once more. N factorial whole square minus 1 over n factorial minus 1 is equal to, in place of n factorial, I will be writing a. So, a square minus 1 over a minus 1. And we have the algebraic identity a square minus b square. This is equal to a plus b times a minus b. Now, this 1 can be thought of as 1 square. Okay. So, this is a square minus b square where b is equal to 1. So, the numerator becomes a plus 1 times a minus 1 and the denominator is a minus 1. Okay. Now, we may cancel these two and our answer will be a plus 1. So, what is the value of a? It is n factorial. Therefore, our answer is n factorial plus 1. In case you feel that dealing with factorial notation directly is difficult for you, just write this, let a be equal to n factorial, or you may take any other variable. You may take x, you may take any other variable. Okay, and in place of n factorial, you simply substitute that variable. Do the calculation, come to the final form of simplified form, and then substitute back the n factorial. Okay. So this is an extremely easy question, though I have seen students getting confused because of this factorial notation. So let us move on to the next question. So the next question is simplify 2n plus 2 factorial times n factorial whole square over n plus 1 factorial whole square times 2n factorial. Let's start with our answer. I had started this binomial theorem chapter with the factorial notation. I have done 2 videos on factorial notations questions related to factorials. And what did I say over there? If you are having 2 factorial notations or 2 factorials and you have to simplify, then always express the larger number factorial in terms of the smaller number factorial. Over here we are having 2n plus 2 factorial and this is 2n factorial. Obviously 2n plus 2 is greater than 2n. So we will be expressing 2n plus 2 factorial in terms of 2n factorial. Okay. So we start with the 2n plus 2. And the factors will just go on decreasing in steps of 1. So it is 2n plus 2 minus 1 and then 2n plus 2 minus 2, and now we stop because 2n plus 2 and minus 2 will be giving us 2n, and we are having 2n in the denominator, so we stop over here. 2n plus 2 minus 2 factorial, because it will be just moving on, it will be continuing till we come to 1. But we do not want to expand the entire 2n plus 2 factorial totally. We come to 2n factorial and we stop. Okay. And the next factor is n factorial whole square. Obviously, these two are multiplied together. And then n plus 1, if we take n plus 1 and n, again n plus 1 is the bigger number. So we will be expressing n plus 1 factorial in terms of n factorial. So it is n plus 1 times n plus 1 minus 1, which is equal to n factorial, and this is getting squared. And it is 2n factorial. Okay. So this is equal to, I can take out 2n plus 2. I am taking out 2 as the common factor. You may keep it as it is also. Doesn't matter if you keep 2n plus 2 as it is. Okay. It's not mandatory that you have to take out this common factor 2. And this is 2n plus 1. Next, it is 2n factorial. And n factorial, this is 2n factorial. This is n factorial whole square over, now n plus 1 whole square times n factorial whole square. So it is n plus 1 to the power of 2 and n factorial to the power of 2 and 2n factorial. So these two will be getting cancelled, these two will be getting cancelled, and we are having n plus 1 over here, and this is, that is why I had just taken out that 2. But doesn't matter, if you don't take out this common factor 2, you will be just multiplying 2n plus 2 times 2n plus 1, you will be getting a quadratic expression. And if you factorize that quadratic expression using the middle term splitting method, you will be coming to these two linear factors. Okay. So that is why I am saying that taking out this common factor 2 is not essential. If you have 2n plus 2 and 2n plus 1 and you multiply them one by one, get the quadratic expression and then factorize, you will be getting this form. Of course, that will be taking 2 to 3 more steps, but you will not be arriving at some other answer or arriving at some incorrect answer. Okay, you will be coming up to this point. You will be coming to this point. Okay, so this is equal to 2 times 2n plus 1 over n plus 1. Okay, so you see the questions related to factorials are really very easy. In our next session, we will be solving equations related to factorials. But even though we are seeing that these are so very easy questions, some students get confused. They just have phobia with this factorial notation. As soon as they see 4 factorial notation in this single question, that means this question should be extremely difficult to solve. They will be coming up with this fixed idea that since this question is having 4 factorial notation, this question has to be super difficult, which you see is totally incorrect. Okay? So students, this brings us to the end of this session. We meet again very soon. Thank you for watching this video till the end. Please like, share, subscribe and comment if you find this video helpful. So bye for now.